So we are going to rows. How do we simulate a series? You should know this by now. Well, we need to see first, let me go ahead and set that. What function did we use last time? Let's see. Specify the length of the series, so give me a number between 100 and 150. 170, okay. So the length of the series n is 117, and we've got to specify the model. We'll stick with AR. We need to specify the AR part and then the MA part. The root will certainly lie outside the unit circle for this case. So my series is X. What is the first step that you do once you get a series? Just like linear regression, the very first step is to four-letter words, start plot. So plot always. Start its time, voila, just some magnitude with amplitude for measurement. Put it over. That is the picture that I get. So it's stationary, yes. So the zero line is right there, so why not add that? Add line horizontal. I would say it's stationary. Another way to check is to get an ACF plot, ACF for X. Good. We put in an AR1 model. Look at that picture. And it looks like there's a lot of correlation going on. How many steps are we going? We have to go this way. How many log values? That's our significant. 6. You know, that's borderline case I can draw that. I have to go that far, correct? So it seems like based on the autocorrelation function, I will have to fit an AR6 model. That doesn't make any sense. I simulated an AR1 series. Good. What is that on the side? To determine an AR model's order, we typically don't use an ACF. I'll address that soon. An ACF is a bad choice to determine the order of an AR1 model. Sorry, an AR series in general. There is something else, but to start, we will address that later. But for now, okay, from the looks of it, there is correlation, great. I'm going to find the correlation with log of 1. So that is my series. I have 1 all the way up to 170. If I have to find xt minus 1, what should the values be? I have to log by 1. xt 1 all the way up to 117. I need xt minus 1, so what should the time values be? Log by 1. So they log can't hit
0 to 116.
0 to 116. Now here comes a huge problem. Well, we don't have except 0. We are starting at 1. What do we do? Abort mission. We can do a simple trick. How about we go from 2 to 170. Subtract 1. I'll end up 1 to 116. Yes? Still log 1. Agreed. So I'll call it x naught t. That simply means the original series I'm looking to at time step 2 to 170. The large version, 1 step log. One to 116. I want to find a correlation between the two values. That's what we are interested in. xt correlated with xt minus 1. So by all means, we are finding row 1. Well, easy to find. COR stands for correlation. xt, comma, 1 log, by all means, it is xt minus 1. Good. Okay. Let's see what we get for row 1. Brilliant. Pace 0 is a function that is used to concatenate values with a string. So whatever that is in green, I'm going to combine it with the value of row. I'm going to round the value of row to 4 decimal places. If it is too confusing, I can indent it this way so you can see where I'm opening and closing braces. Okay, let's see what we get. I'm getting 0.7965. Yes? Now look at the picture 0.7965 right over there. Yes. So sure, I can do it this way, or I can simply pick out values from the picture. Entirely up to you. Or do I have to guess the values? No. Go back to where we created ACF. I'm going to assign it to a variable. It will still plot the source. It plotted. But this time, since I saved it to a variable, I can type row. And that is giving me all the values that I need. So row, correlation in 1 step, 2 steps, 3 steps, 4, etc. Good. So I know row 1 is 0.791. Okay. P2 autocorrelation matrix, we know that it's got 1, row 1, row 1, 1. So in R, you can create a matrix by putting in the values inside the function matrix, but you've got to put C open paren close paren to define a list of values. So 1, row 1, I already have the values saved. So row 1. Row 1. Good. Number of rows 2, number of columns 2. Something very important. Should you do it by row or not? By row would mean you take the values and put them in order row by row. By default, R is going to do it column by column. What do I mean by that? For instance, if I simply have matrix say 1, 2, 3, 4. Number of rows is 2, number of columns 2, and 1, 2, 3, 4. I don't want that here because I have 1, row 1, row 1, 1. I want things to go this way. So if you add I row equals true, 1, 2, 3, 4. That's what I want. If I set it to true, 1, row 1, row 1, 1. So by row equals true. What did I do? One of those things about that's not a vector, it's actually a list. And I actually have to pick the second element because the first element is 1, 0, 0. So the way things are saved, it is not a simple list, rather it is a list within a list. So you need one other statement, row, unlist, row. Now you can see whatever that I had earlier turned into this log 0, log 1, log 2, log 3. You don't have to worry about the names that I've given. Ignore that for now. See if I can do it another way. List. Right.
Row 2.
What do you mean, row 2? Oh, I see why. Never mind. It's a list within a list, which is why I need to do all this extra work. So that is by default. I'm going to do row ls. So this is what I meant by list within a list. It's when I assigned ACF to a row, it simply didn't assign one value, rather it assigned the ACF, it assigned the lag, it assigned the number of observations used, the original series, and 2 other things, right? If I simply want to access the ACM, let's see, people who took computational technology with me, I know there are 3 of them here. So how do I access ACM, which has the correlation values?
I would do rows and then brackets 1 and then brackets 2.
Okay, money, dollar, ACF. That will give me all the autocorrelation values. Good. Instead of unlist, which was a bad idea, I can do row. All I need is the ACF part. Let's go ahead and run that also. 3 decimal. Good. Everything went peachy. We can look at our matrix, E2. One, because the first element of row is the toolbar at 0. So we need the second line, vertical line. So row 2. 1.7907, 0.7907, 1. So I have 1, row 1, row 1, 1. That's my measurements from earlier. Okay. If I want to find the determinant, start using 0.37479. Do we consider that to be positive? Easy question. Is that positive? Okay. I will post this script also. Determinant B2. Okay. So correlation, lab 1 is 0.7965. Determinant, I have 0.3748. I want to know if it is invertible. It is going to be. So how to invert a matrix in R? Can't take it. How do you invert a matrix in R? Don't have to do it manually. Forgot.
It's all.
It is solved. Very good. It is going to be inverse. So, source. Ended up getting that matrix, which is the inverse of V2, invertible. Eigen is a function that is going to give us eigenvalues. And it's eigen V2. Those are the values that I'm getting. If you look at the eigenvalues of the matrix V2, both of them are positive. Positive, semi-definite. Good. That's what I meant by positive, semi-definite. Multiple ways to come to that conclusion. Well, you could try and invert it. If it is invertible, then symmetry, positive, semi-definite, which is why it is invertible, stationary series. Another. So this is invertible, which would mean I have a stationary series. We know we have a stationary series because that's what we started with. Another way is to get eigenvalues. Of the matrix, original matrix, and I'll just print it. That print statement is going to print the eigenvalues for me. So I've got positive eigenvalues, so stationary. Good. When R simulates a Remus sim, it is going to do all of this in the background to make sure if it is simulating a stationary series or not. If you recall, the last time we did a Remus sim, I chose a bunch of coefficients and it threw an error. Series is not stationary, or model is not stationary, because R is doing all this work in the background. So, slowly building things up. In practice, you get a series, you plot the series, you can look at the plot, come to a conclusion as to whether the series is stationary or not. If it is stationary, we can use stationary models to fit the series, make predictions. How do we know something's stationary? One, instead of doing guesswork, I can go up here, see if I'm able to invert the matrix. If it is invertible, I've got myself a stationary matrix. If that is too hard to do, you can find the eigenvalues. You can use the eigenvalues to determine if we have positive semi-definiteness, that would imply stationary. Good. So, observation, observe a series, plot the series, look at it, do some guesswork, just like you would do with the scatter plot. Do you see a pattern? Is it linear? Is it non-linear? If it is linear, you go for a linear model. If it is non-linear, you go for a non-linear model. Same logic, you plot it. That, from experience, I know is stationary. If you're not able to pick that out, do this, stationary. If you don't want to do the guesswork, you can do that and determine if the series is stationary or not. Once we make that conclusion, you either fit a stationary model or you fit a non-stationary model. Is it okay to fit a linear regression model to non-linear relationship? Absolutely not. Sure, you can use the math and get a bunch of numbers, but whatever you did, it's wrong. It's garbage. Same logic. You can't take a stationary series and fit a non-stationary model. Vice versa. Good. Okay.